welcome to this session. This is all about the families of curves. So, under the families of curves, we have to obtain the differential equation of the family of plane curves described. So, how do we do that? We also have your solution. So, number one, you have to distinguish first the family of lines or curves to formulate the equation to be used. So, kailangan alamin mo muna kung ano yung working equation mo o kung saan manggagaling yung working equation mo. It can be straight lines, it can be circles, or it can be parabola, and so on. So, after knowing your working equation, you have your number two, which is apply the method of elimination of arbitrary constant. So, if you have your working equation, you have to identify the arbitrary constant and you must eliminate the arbitrary constant for you to be able to have the differential equation of the given family of lines or curves. So let's start with the example. Okay, example number one, you have straight lines through the origin. So, meaning to say, you have any straight lines which is passing through the origin. So let's say you have your Cartesian coordinates, which is the x and the y, then identifying the origin, which is the 0, 0. So any line na dadaan dun sa point na 0, 0 or the origin. Pwedeng yung blue line, pwede rin yung violet line, pwede rin naman yung green line, and lastly, pwede rin naman yung yellow line. So kahit alin sa kanila, basta dadaan dun sa origin, yun yung kukuhanan natin ng differential equation. So first, kailangan alamin mo muna kung ano yung gagamitin mong equation. So syempre, we are talking about straight lines. We have to use the equation of the straight lines. Now, the equation of your straight lines or the general form of the equation of the straight lines is y minus k equals m multiplied by x minus h. So, dito manggagaling yung working equation natin wherein yung h and k is a point na dadaanan nung lines na tinutukoy dun sa example. So, identified na ang dadaanan nila or lahat ng lines ay may dadaanan na 0, 0. So meaning to say the values of h and k is equal to 0. So i-apply natin yung h and k dun sa general equation. You will now have y equals mx. So this is now your working equation. So dito manggagaling yung i-eliminate mo na arbitrary constant. Pero bago mo i-eliminate yung arbitrary constant, you have to identify first which is the arbitrary constant. So in this equation, m is considered as your arbitrary constant. So therefore, you only have one arbitrary. Since meron kang isang arbitrary, you have to obtain first derivative. Since first derivative of the equation is y, you will have y prime, then the mx, the derivative of mx is simply m. Now, after obtaining yung first derivative, napansin natin na hindi pa rin na-eliminate si m. So, anong gagawin natin? We have to copy the original equation which is y equals to mx. Tapos, kukunin natin yung equation ng first derivative, isa-substitute natin dun sa original equation, magkakaroon na tayo ng equation na y equals y prime multiplied to x. But taking note that y prime is equivalent to dy over dx, so ang magiging equation na natin is y equals dy over dx multiplied to x. Now, simplifying this equation, paano natin siya isi-simplify? Siyempre, multiply natin siya sa dx. The whole equation will be multiplied to dx. So, distributing the dx, you will now have y multiplied to dx, that is y dx. Then the dy over dx multiplied to x multiplied to dx, makakancel si dx. You will now have x dy. Then simplifying again the equation by transposing x dy to the other side, you will now have the equation as y dx minus x dy equated to 0. So since simplified na yung equation, the final answer or the differential equation of any straight lines passing through the origin is said to be y dx minus x dy equated to 0. Now let's go to example number 2. Example number 2 talks about straight lines passing through a fixed point, which is the h and the k. So any straight lines na dadaan sa fixed point, which is h and k yung value. So let's say you have your Cartesian coordinates again, the x and the y. Then identifying your h and k or the fixed point given. So any straight lines na dadaan dun sa fixed point, which is can be the blue line again, the violet line, the green line, or the yellow line. So any of that straight lines basta dadaan dun sa point na HK. So the same equation, you have to use the equation of the straight lines. Then the equation of the straight lines is said to be y minus k equals m multiplied to x minus h. Ngayon, hindi na 0 yung value ni h and k kasi wala na siya sa origin. Pero, sinabi na fixed point si h and k. So, meaning to say, hindi mo siya kailangang i-eliminate kasi fix yung value niya. Arbitrary constant is said to be many values or pwedeng iba-iba ng values. So, ang iba-iba lang ng values dyan is yung m, which is the slope of the line. Kasi pagka naiba yung angle ng lines or straight lines, naiiba din yung slope of the line. So, m is the only arbitrary constant in the equation. So, you only have one arbitrary. So, m lang yung kailangan mong i-eliminate. So, in that case, you have to obtain first derivative of the equation. So, pag nag-first derivative ka, y is y prime, k is 0, then mx is m and h is both constant, then the derivative of constant is 0. So, ang equivalent ng first derivative mo is y prime equated to m. So, in that case, you have to copy again the original equation para magamit mo yung equation ng first derivative. So, substitute natin dun sa m. We will now have an equation of y minus k equals y prime multiplied to x minus h, wherein y prime is equal to dy over dx. So, papalitan natin si y prime ng dy over dx. Ang magiging equation mo na ngayon is y minus k equals the quantity of dy over dx multiplied to x minus h. So, simplifying that equation by multiplying the equation by dx, ang mangyayari natin ngayon, you have to distribute the dx. So, ang mangyayari, you will have y minus k dx equals x minus h dy. Hindi mo kailangan eliminate si h saka si k kasi fix yung value niya. So, hindi siya considered as arbitrary constant. So, meaning to say, this is your differential equation. All you have to do is to simplify. So, by transposing x minus h dy to the other side, you will now have an equation of y minus k dx minus x minus h dy equated to 0. So, the differential equation of the straight lines passing through the fixed point, which is the h and the k, you have the quantity of y minus k dx minus the quantity of x minus h dy equated to 0. Then let's go to example number 3. Okay, example number 3 is a straight lines with slope and y-intercept said to be equal. So in that case, you need to use the equation of a straight lines in y-intercept form. So the y-intercept form equation is y equals mx plus b, wherein m is the slope and b is the y-intercept. Then slope and y-intercept is said to be equal. So your equation now is y equals mx plus m. So in that case, hindi naman sinabi na fix yung value ni slope and ni y-intercept. Ang sinabi lang, they are just equal. So it can be changing. So pwede siyang maging considered as arbitrary constant. Therefore, m is your arbitrary constant. Since isang klase lang yung arbitrary constant mo, you have to obtain hanggang first derivative lang. So your first derivative is y, wherein you have y prime, then si mx, you have your m, then si m is considered to be 0. So ang mangyayari ulit, you'll have to copy the original equation, which is y equals mx plus m. Tapos isa-substitute mo ulit si y prime equals m dun sa parehas na m. So your equation will now be y equals y prime multiplied to x plus y prime. And taking note that y prime is equivalent to dy over dx, you will now have an equation of y equals the quantity of dy over dx multiplied to x plus the dy over dx. Then multiply the whole equation by dx. We will now have y dx. Then this term multiplied to dx, makakancel si dx. Ang matitira is x dy. Then this term multiplied to dx, ang matitira na lang is dy. Now you will notice in this side, common si dy. So ilalabas natin. You will now have an equation of y dx equals the quantity of x plus 1 dy. So simplifying this equation by transposing this to the other side, you will now have y dx minus the quantity of x plus 1 dy equated to 0. So the differential equation of the straight lines with slope and y-intercept equal is y dx minus the quantity of x plus 1 dy equated to 0. Next is example number 4. Now we have circles with center at the origin. So any circle, basta ang center niya nasa origin. So let's say you have your Cartesian coordinates, the x and the y, identifying the origin ulit, that is your 0, 0, wherein nandun dapat yung center ng circle. So it can be the green circle, or pwede din naman yung violet circle, or yung yellow circle, and lastly, it can be the blue circle. So basta yung center niya nasa origin, pwede namang magkakaiba ng size yung circle. Then, all you have to do is to identify kung ano yung equation ng circle. So the general form of the circle is the quantity of x minus h squared plus the quantity of y minus k squared equals r squared, wherein h and k is identified as your center and r is identified to be the radius. Tama po. Then, since si h and k ay nasa center, the value of the h and k is 0, 0. Tapos si radius, hindi naman sinabi kung gaano kalaki yung circle at hindi rin naman sinabi na fix yung radius ni circle. So r is changing. So your equation now is x squared plus y squared equals r squared. So in that case, the identified arbitrary constant is your r. So meaning to say you only have one arbitrary, so you have to obtain the first derivative of the equation. Now the first derivative of the equation is said to be 2x, then y squared is equivalent to 2y, y prime, then si r is constant, so ang equivalent niya is 0. So in that case, simplifying the equation by putting y prime into dy over dx. So ang equation mo na ngayon is 2x plus 2y multiplied to dy over dx equated to 0. Then next step is multiplied yung equation sa dx. You will now have x dx plus y dy equated to 0. So the differential equation of the circles with center at the origin, you have x dx plus y dy equated to 0. Next example, example number 5, you have the circles with center on the x-axis. So let's illustrate yung given. Let's say you have your Cartesian coordinates. Circles with center on the x-axis. Ayun yung center niya sa x-axis. Next circle, ayun yung center niya sa x-axis. Then another circle, nandun pa din yung center niya sa x-axis. And lastly, andun pa din yung center niya sa x-axis. Kung mapapansin nyo, basta yung center niya nandoon lang sa x-axis, tapos kahit ano yung size ng circle, pwedeng maliit or pwedeng malaking circle. Basta dapat yung center niya nandun lang sa x-axis. So the equation to be used is the equation of the circles, of course. Equation ng circle, you will have the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. So i-apply natin yung given condition. Since nasa x-axis lang yung center ng circle mo, ang may value lang sa between h and k is only the x, or considered to be the h. Meaning to say, your center na h and k will be h and 0. Kasi si k, in this case, the value of the y, since nasa x-axis nga lang siya, it would be 0. Pero si h, pwede kahit saan sa x. So meaning to say, nagbabago-bago yung value ni h as well as the value of the r, nagbabago-bago din yung value ni r. Kasi pwedeng maliit yung radius ng circle or pwedeng malaki yung radius ng circle. So our equation now is the quantity of x minus h squared plus y squared equals the r squared. So in that equation, i-identify natin yung arbitrary constant. You have the h and the r as the arbitrary constant kasi nga si h pwedeng magbago. Si r pwede ding magbago. So you have two arbitraries. Then you have to obtain up to second derivative of your equation. So let's get the first derivative. Ang first derivative natin is 2 multiplied to x minus h plus the 2y y prime equals 0. Now we have to get the last derivative, which is the second derivative, and that is this term, ang derivative na lang niya is 2, tas this one is said to be product. So copy 2y Then the derivative of your y prime is y double prime. Then copy y prime. Then the derivative of your 2y is 2y prime, and that is equivalent to 0. In that case, eliminated na natin yung parehas na arbitrary constant, which is the h and the r. So all you have to do is to simplify the equation by dividing the equation into 2. So ang mangyayari, you will now have 1 plus the quantity of y multiplied to y double prime plus y prime multiplied to another y prime, then equated to 0. So your differential equation for any circles with centers on the x-axis, that is y double prime plus the quantity of y prime squared plus 1, then equated to 0. Now let's go to our last example, which is example number 6. This is all about the parabolas with vertex on the x-axis, with axis parallel to y-axis, and with distance from focus to vertex fixed as a. So let's illustrate the conditions. First, you have the x and y coordinates. So we have the parabola. It can be downward. Tapos, vertex on the x-axis rather. So yung vertex mo nasa x-axis. Then si axis daw parallel kay y-axis. So it satisfies yung second condition. Then the last condition is yung distance from focus to vertex would be fixed as a. Then another parabola, downward again. You have the vertex on the x-axis, then axis parallel to y-axis, then the distance from focus to vertex will be fixed as a. Then another condition of the parabola, it can be upward. Then the vertex is also at the x-axis. Tapos, axis is parallel to y-axis. And the distance from focus to vertex will be fixed as a. And lastly, the yellow parabola opens upward, vertex at the x-axis. The axis is parallel to y-axis, and the distance from focus to vertex fixed as a. So kahit alin dyan sa parabola, dapat masasatisfy niya ito. So all you have to do is to get the differential equation of these parabolas. So syempre, we have to use the equation of the parabola facing upward or downward. So in that scenario, we have the formula, which is the quantity of x minus h squared equals plus or minus 4a multiplied to y minus k. So i-apply natin ngayon yung condition. H and k is said to be the vertex of the parabola. So si h is the x coordinate. So kahit saan sa x, pwede yung vertex ni parabola. But kung nakalay ka dun sa x-axis, meaning to say the k, which is the y coordinate, is said to be 0. Tapos, ang sabi kanina, a is fixed. So, ibig sabihin, a is not considered as arbitrary constant. So, our working equation now is the quantity of x minus h squared equals 4ay. In that working equation, h is considered as arbitrary constant. Bakit? Kasi a is said to be fixed. So, pag fixed yung value, hindi siya considered as arbitrary constant. But h is changing since pwede siyang mag-lie anywhere under the x-axis. So, pwedeng magbago yung value ni h. Then, since you have one arbitrary, you have to obtain hanggang first derivative lang. In that case, the first derivative of the equation is 2 multiplied to x minus h equals 4a. Then the derivative of y is y prime. But in that case, hindi pa natin na-eliminate si h. So what will we do? Let's simplify first yung equation na to by dividing it sa 2. So ang magiging equation natin ay x minus h equals 2a y prime. So paano natin tatanggalin si h? So we will think of a way na kailangan magamit natin yung original equation as well as our new equation dun sa first derivative equation. Now, yung first derivative equation, pwede natin siyang i-square both sides. In that case, we will now have an equation of x minus h squared, then the quantity of 2ay prime squared. So simplify first. We will now have the quantity of x minus h squared. Then 2 squared is 4. A squared is a squared. Then y prime squared. Now if you will notice, this equation has a similarity in the original equation. Parehas silang may x minus h squared. So, pwede natin kuhanin yung original equation to substitute dun sa nagawa nating equation from the first derivative equation. So, pag ginawa natin yon, we will now have an equation of 4ay equals the 4a squared y prime squared. Then, simplifying this equation by dividing the equation in 4a, magkakaroon na tayo ng panibagong equation which is y equals a multiplied to y prime squared. Now, in this equation, h is your arbitrary constant and you will notice that this equation doesn't have h. So, na-eliminate natin si arbitrary constant. Now, the differential equation of the parabola with the condition vertex on the x-axis, axis parallel to y-axis, and with distance from focus to vertex fixed as a is y equals a multiplied to y prime squared. So that's all for the families of curves. I hope you learned a lot in this session. Thank you and God bless.